So, hey, good morning, everyone. Thank you for joining us today for this session. So, let me first tell you about Learning Saturday. So, it's an initiative that is being organized every month by Mindbrowser, mostly on the last Saturdays of the month, where a team shares their new learnings on different topics on from different tech stacks. So, for upcoming events, you can follow our social media channels. So my name is Hardesh Kumar, and I'm a full stack developer here at Mindbrowser. I have around 4 years of experience in development, and I mostly work on MERN stack. Next, I would like to introduce Nihar. So Nihar is also a full stack developer, but he uses Python in the backend. So in today's session, we're going to talk about GraphQL. I'm really excited to be here to talk about this innovative query language and runtime for APIs. Yeah, so before we get started, let me give you a brief overview of what we will cover today. So we will begin by discussing what GraphQL is and how it differs from other API technologies. Then we'll explore the benefits of using GraphQL and why it has become so popular among developers. Next, we will dive into the technical details of how to design and implement GraphQL APIs. We'll also look at the key components of GraphQL schema, how to define queries and mutations, and how to optimize your GraphQL queries for better performance. Finally, we will wrap up with a Q&A session where you can ask any questions you have about GraphQL or its applications. But first, let me start by asking, have you ever found yourself frustrated with traditional REST APIs? Perhaps you've experienced issues with overfetching or underfetching of data, or struggle with the complexity of managing multiple endpoints. If so, you are not alone. These are common pain points for developers working with traditional APIs. So that's where GraphQL comes in. GraphQL allows you to query your data in a flexible, efficient way without the overhead of multiple endpoints or unnecessary data. And with GraphQL, you can request exactly the data you need in the format you need it, and which makes it a powerful tool for building modern APIs. So without any further ado, let's dive in and explore the world of GraphQL. So what is GraphQL? GraphQL is a query language and runtime for APIs, which was developed by Facebook. So it enables client to request and retrieve data from servers in a flexible and much more efficient manner. So if we compare it with traditional REST APIs, where the server dictates what data is written in response, with GraphQL, the client specifies the exact data it needs and receive only that data in the response. So here client plays the major role. So whatever the queries we have to write, those queries are written at the client side. So this allows for more efficient data retrieval, reduces network traffic, and improves the performance. Now, if we talk about the difference uh, of GraphQL from REST API, so however, both these technologies are used to communicate with servers over the web, but there are several differences between these two. First one is data retrieval. So when it comes to data retrieval, with REST, clients typically make multiple requests to different endpoints to retrieve the data. So each entity is assigned to an endpoint. So whenever we want to fetch some data for particular entity, we have to call the API endpoint related to that entity. Then only we can get the data. But in GraphQL, we can make a single request and specify the exact data we need in a query. So we can get bulk of data in a single request itself with GraphQL. So this reduces the amount of data transferred over the network and hence improves the performance. Second one is response format. So in REST APIs, the data is written mostly in the predefined format such as JSON or XML, whereas GraphQL returns data in a structure that matches the query of the client. So we in the front end itself, in the client side itself, define how like in which uh, format we want the data in the response. So this means that the client receives only the data they need without any extra keys or extra information. So if we take the example here, let's say a user object contains 4 fields, and in the query in the front end, we are just saying we want only the name and the email of the user. So in the response, you will get only the name and the user. Then third point is schema definition. So GraphQL mostly works. GraphQL has a schema that defines the available data types and operations that can be performed on the data. So this schema is self-documenting, which makes it easier for clients to understand how to interact with API. In contrast, REST APIs typically rely on documentation uh, that is already separate from API itself. So those of you who do not know about schemas, so we're gonna cover the schemas in much more details in the coming slides. And then we have versioning. So like whenever there are some changes in the APIs, REST APIs, so which like we have to give versioning to those APIs, so which can lead to the duplication of endpoints, and also it confuses the clients also. But with GraphQL, the schema acts as a contract between the client and the server. So the schema plays a major role here. So whenever we make changes to the GraphQL schema, we are creating a new version of schema. So whenever there are some changes, whenever there are some updates, we can just update the schema and we can create a new version of schema. So it will, rather than modify the existing schema, we'll create a new one only. So it will not confuse the client. So we'll have the new schema only for all the queries. Yeah. Then we move to GraphQL architecture. So how here we'll discuss how GraphQL works. So basically, GraphQL has three-tier architecture that consists of client, server, and database layers. The first one is client layer. So the client layer is responsible for sending requests to the server and receiving responses. A client can be a web or mobile application, and they can use any GraphQL client library to interact with the server. So to interact with the, like whenever we are using GraphQL, we need to have some client library at the client side, so that we can make queries and can make requests to the backend to the server, so that we can get the response accordingly. Then we have this second layer, which is server layer, where the GraphQL resides. So in that layer, the server receives the request from the client. So whatever the request client sends, the server receives that request and process them. And the server also has a GraphQL schema that defines the available data types and operations. So that schema, in that schema, we already defined that these are the operations that we can perform for this particular schema, and these are the types. Types, we can say a real world entity, we can convert it to a type. So in a schema, we define that these are the types and these are the operations that we can perform on this particular data. And then the server, what the server did is it retrieves data from any of the data sources. So data sources might be a database, or might be any other REST API. So data source can be anything. So it retrieves the data from the data source and then again returns back into the client after processing it. And the last layer is database layer. So database layer mostly we deals with the storing and storing of the data. So this is the basic architecture of GraphQL. Then now we will talk about the key components of GraphQL. So there are some components which plays a major role in GraphQL. So we mostly talk about the main three components. So first one is query. So a query, where we can say a query is an operation which defines like what you want to do. So let's say if a user wants to, so queries are mostly, we use queries mostly when we want to retrieve some data from the backend, from the server. So that time we use queries. Then we have resolver functions. So resolver functions are responsible for retrieving the requested data from one or more data sources. So it might be a database, or it might be another REST API. And these resolve functions only process the query against the schema. So whatever schema we have created in the database, so it will process the query and then return the requested data to the client. So whatever the client has requested, it will return the data to the client. And based on the, it will like match the response with the query, what the query the client has given. So the response has to match with this query. And in the last, we have schema. So schema is a combination of types. So it is a kind of central component where we can define the types, the operations, and it also plays a contract between the client and the server, that which ensures that the client will get only the requested data, not anything else. So these are the main components of this GraphQL, and in a query we have fields and arguments also. So arguments are the fields, arguments are like whenever we passing some, let's say you want to fetch some data related to particular user or a particular entity. So that time we have to somehow give some unique key for to fetch the data for that entity. So that, let's say ID of a user. So that ID we pass to that function, to that query, is an argument. And fields are like whatever the fields that exist for that a particular entity. Let's say a user might have name, username, then it might have age, and other fields also, email address, and so on. So these are fields and arguments. Yeah. Now we will go in depth and discuss what is GraphQL schema. So GraphQL schema, we can say it's a kind of blueprint where we are saying that this API can do this much stuff. This API can fetch these types. This API can perform these many operations. So if we are defining, let's say only a GET request, so wherever we are only fetching the data from the server, so that time this schema on like will define the all the GET requests in the schema. So and whenever the client requests the whatever like calls the function or requests that query, that time they can only perform the GET request, and to perform the uh, other post delete request, for that we use mutation. So we'll also cover that in the coming slides. So a schema consists of uh, following things like types, so that we have already told. So like types are like kind of uh, whatever data, what kind of what type of data you want to store. So type can be scalar types. So scalar types are like normal string types, boolean types, and integer types. It can be of object types also, and we can also define a developer can also define a custom their custom types. And in the types we have fields. So fields are like single values. So like, let's say name of the user is a field, and username of a user is a field. uh, then for the schema we have queries. So queries, whenever we are talking about retrieval, that time for that we require queries. So query define the operations that can be performed to retrieve data from the GraphQL API. So whenever there is data retrieval, that time it's kind of get request. So whenever like we have get request in REST APIs, so it is same like that. And at last we no on the like second last we have mutations. So mutations define the operations whenever we are planning to modify the data in the database or at the server side. That time we will use mutations. So it is same like post, delete, and create request as in REST APIs. And at last we have subscriptions. So subscriptions deal with the real-time updates. Like you might have heard about WebSocket. So it's we somehow like using subscription. We somehow open the like keep the connection between the client and the server open, and whenever there are some changes on the database, that time it will you will get notified. Now, yeah. So now we will define we will get to know, we will learn about like how to define a schema. So normally a schema we define using a schema definition language. So a schema definition language is just a human readable way. So it's to, like normally it's how like we can define the types and the fields and the relationships in GraphQL API. And then so a schema consists of types. So types we have already covered. Then fields also. So fields we have already discussed, like like each key in a type. And then we have queries and mutations. And at last, after defining all these things, we'll compile a schema. So at the compilation time, what we do is, so once we define all these fields, like all these types, fields and queries and mutations, so we'll somehow edit all the things, all the operations and all the types schema will have. And then we will compile it using some GraphQL schema builder or SQL parser. So this will generate an object that we can use to validate or execute our queries. So yeah. And yeah, here we can see a simple example of a schema. So this is how we can create a schema in GraphQL. So if we talk about this particular schema, so this schema defines a query. So in the first type, we can define a query using query keyword. And then we have two types here. One is user type and one is post type. So like we are defining like if we are fetching the user type data, so that user type will have these many keys, these many fields: id, name, email, post. And same for the post also. So if we are fetching some data for the post, so that post must have these many fields. And at the last we have mutations. So mutations, like as I already told, whenever we are trying to modify some data, that time we will use mutations. So like creating a user, so it's kind of a post request to the database, and we are somehow modifying the database. So that's why it's a mutation. And if we want to delete a user also, that also we have to give it the mutation only. And for updating a user also, that request will also goes to the mutation. So now if we talk about the queries one by one, so this first query which says that user, and after that it is saying that it will return an array of users. So whenever we call this query at the front end, so it will return all the users that exist, and along with the fields. So those users will contain id, name, email, and post. And same for the user, same for the second one also. So but second one, we are passing a parameter here, the argument here. So the argument, when so here we are saying that we only want a user that matches with that id. So whatever id you pass here, you will get only that particular user. Same for the post. So for post will return all the posts, whereas whenever we are passing id as an argument, it will return only a particular post that exists with that id. Yeah, now we can move ahead. So yeah, here we will talk about the different types that exist in a GraphQL. Yeah. So first one is scalar types. So scalar types represent a single value, such as an integer or a string. Uh, some examples of scalar types in GraphQL include like we have like in other languages we have string, float. So same like this we have in GraphQL also. But here we have one ID type also, which defines the unique ID. Then we have second one is object types. So object type represent a collection of fields, uh, each with their own name and value. So we will give the name, particular name, and a value to that field. So it's a combination of fields, and you can define custom objects to represent data in our API. And then at the third place, we have list types. So list types are same as arrays. So whenever we want to give some multiple values in a single variable, that time we will use these list types. So we can define a list type by adding a square bracket. And let me show you the example. Yeah. So if we see the first user and user, so it says it's a list which says it's an array of users, and the type of that user is user. So this is a list. And yeah, then we have non-null types. So non-null types are like we can define those types using the exclamation sign. And these types says that this field, this particular field cannot be empty, and this field must always be present. uh, we can see an example here. So let's take the, yeah, so here if we see that user type, and in the user type we have id, and after the id we have this exclamation sign. So this sign says that we are saying here, we are saying to the GraphQL, this field is always required, this will always be present. So if you are not passing this field, or if this field is not available, that time our GraphQL will throw the error. So saying that this field is does not exist and it is required. And then we have enum types. So enum types, like whenever we want to represent some fixed set of values, that time we will use enums. um, like we can take the simple example of colors. So like whenever we want to represent some fixed set of colors, so that time we can create a enum for color, and then we can use that enum everywhere along with those whatever colors we had defined, along with those values. And at last we have input types. So input types, mostly in GraphQL we use input types for passing the arguments. like mostly in the mutations. So whenever we like to, like, let's say if we talk about this mutation, create user mutation. So here we have to pass some data to create a user. So if we take a simple example, it's like we have to at least pass the name and email of the user to create a particular user in the database. So to pass those arguments, we have to pass. We have two ways. Either we can pass them separately, or we can use an input, so which will combine both username and name of that particular user in a single value, and then we can pass that user input in a single argument. So we do not have to separate out the arguments here. So that's where uh, this inputs in GraphQL are useful, and inputs are defined using input keywords, and they are somehow similar to regular GraphQL objects only, but are intended to represent a collection of input values rather than a single entity. Yeah. So now we can move to the next slide. Yeah. Here we will talk about how to query, like how we can write a query from the front end, like how to query a server, GraphQL server. So first, what is a query? So in simple terms, a query is a request, is like to a some specific data from the server. So like whenever we want to fetch some data, in GraphQL we use query only when we want to retrieve data. So it's kind of a get request only. So only whenever there is a case of retrieval, there we will use query. So whenever there is request to some specific data from the server, that time we use a query. And in GraphQL, a query is made of three parts. So first one, like what is the operation that we want to perform? Then what are the fields that we want to pass to that query? And in the last, query result. So result, what are the fields that you want to get in the response? So these all three things we have to mention in a query. Now we'll look at a simple example of a query. So yeah, so query keyword says here like it's a query, and then we have this user ID. So here we are saying that we have to call this user query with ID 123. So whatever user that exists with ID 123, we have to return that user with fields name, email, post, and post will contain only the title and the body. So in the last, this we are defining like this, only we only want these fields in the response, nothing else. If other fields also exist in the database, we do not want those fields for this query. We can play with these queries also. We can add on multiple fields here, and we can also remove these fields. So whatever, so if you remove name from here, we will get only email and post. That's it. So whatever you are passing in here in the query, like whatever response you want, you will get only those fields. That's it. Yeah. So this is the response for the previous query. So first we will have this data object. Then in the data object we have this user object, and the user of, because we have made this query users, so that's why we have this user object. And then in the user object, because we have ask the server to only send name, email, and post. That's why we are getting only the name, email, and the array of posts. So yeah, so on we are getting only those fields which we requested, nothing else. Then I'm going to talk about mutations. So mutations, what is a mutation first? So as I already told in the previous slides, like whenever we are dealing with create, update, or delete, or like any kind of modification operation we want to perform on the server, that time we will use mutations. And same like queries, mutations are also defined in the same way as of queries. So we will have a mutation operation, then we have mutation fields, and after modifying, what are the fields you want in the result. So that's a mutation result, and it's same as create, update, or delete, deleting of data as of REST APIs. Now we'll see a simple example of mutation. So yeah, here first we are using this mutation keyword. So this keyword says that it's a mutation, and then we have this create user mutation. So it's a function. So what it does is it takes two parameters, name and the email. So once we pass these two parameters, we call this function, and it will do its work in the backend. and after that it will, once the user is created, it will send the ID, name and email of that newly created user. So I'll show you the response also in the next slide. Yeah. So this is the response you will get after creating a user. So once the user is created, so if you will get ID, name and email. So only these three fields you have requested. That's why you have got only these three fields. That's it. From here, Nihar will take you through the remaining slides. Over to you, Nihar, and you can share your screen now.
Yes. Yeah. Thank you, Hirdesh, for explaining all the topics very well. Hey guys, myself Nihar, and I am a full stack developer at Mindbrowser. So now let's talk about subscription. So subscriptions are like queries, but unlike queries, it allows client to receive real-time updates from the server. So it keeps the connection open with the server, like to push the updates to the client as any event occurs. The server-side implementation of subscriptions requires setting up a persistent connections with the client, which can be done by using various mechanisms like WebSocket, SSE, and its name is server-side events or long poll. The subscriptions are commonly used in applications that require real-time data updates, such as chat applications, social media platforms, and online gaming platforms. So, this is how we can create subscription queries to start communication between client and server. Here, subscription queries are similar to regular queries, as you can see, but instead of requesting a snapshot of data, it allows the client to subscribe to a continuous stream of updates. In this example, client subscribed to a message event, right? So when a new message is added to the system, the server will push the update to the client with the specific field mentioned here, like ID, text, author, and created the specific fields. And we need to keep in mind that we should send it over WebSocket connection rather than HTTP request. So here the connection between this client and server established, you can see the response from the server. And here, any new messages posted will come through the same subscription channel. Like this channel name is message. So any new message posted, the same channel will push the response. Now moving to the GraphQL libraries. Here, these are some libraries that provide a set of tools to perform GraphQL operations over any programming language. Like here, some of our server-side programming server-side libraries and some are client-side libraries. Take an example, Graphene. It's for Python programming language, GraphQL Java for Java, and GraphQL Go for Golang. And Apollo Client, Relay, AWS, Amplify. These are some client-side libraries to use GraphQL. Now let's move some real-world use cases. Now you can see these are some real-world use cases. GraphQL gained significant popularity due to its unique features, which make it a good fit for any real-world applications. GraphQL's flexible schema, efficient data fetching make it more powerful for API by allowing clients to request only the data they need. GraphQL support for subscription and real-time data make it a good fit for building applications that require real-time updates like social media platforms, IoT things, and e-commerce platforms. And its ability to handle complex queries or combine data from multiple sources helps for building microservices as well. Now, coming to some benefits and challenges of GraphQL. First, let's talk about benefits. Uh, Flexible querying. So, GraphQL allows client to send the request they need only. It can result in significant performance gains and minimize the data transformation over the network. It has a strongly typed schema which provide more clarity and less ambiguity around the requested and response data. Its flexible schema allows changes to be made without breaking the API, and it has a better documentation which makes it easier for developers to understand and collaborate in a more efficient way. GraphQL provides a simple syntax that's easy to learn and understand. At the same time, it has some challenges as well, like caching. Uh, GraphQL response cannot be easily cached because, as we know, the same query may be requested but with different variables. Sometimes GraphQL can add complexity to the server-side implementation, especially for complex queries that require multiple data resources to be queried and combined. Sometimes GraphQL requires developers to learn a new syntax and way of thinking, which can take some time and may require additional training. There are some security issues as well, where hackers can create queries to expose sensitive data. So this requires some additional attention for security while implementing GraphQL in our project. Now it's time to move to the demo part. In this demo, we'll go through a simple CRUD operations, advanced features like web implementations, subscriptions, authentication will be covered in our upcoming sessions. So for now, I need to jump to my VS Code to show the demo. For now, we have created a Django application named Graphene Demo with all basic setup done and also installed Graphene to use GraphQL features. Also, we have created a separate app for GraphQL operations. Now you can see GraphQL demo. It's a new app. Okay, so for now we have created a Django application named Graphene demo, and all the basic setups are done, and also install Graphene to use GraphQL features. And also we have created the app, separate app for GraphQL operations like this GraphQL demo. Now let's jump to the models.py. Here we have created two database tables named product and category. We keep it simple for better understanding. So here is schema.py file, which contains all the business logic for the module. As Hirdesh mentioned, there is two important things in GraphQL. One is query and one is mutation. So here, coming to the query part, here is the query part, and here it contains all the logic for fetching the data. Here all products are used to get all the products at a single time, and product is used to get individual product details. And these are the class mutation classes. And this is the root mutation class. It is responsible for create, update, and delete operations. Now let's move to see how it works. Okay, here is the graphical user interface provided by Graphene. It's named GraphQL. So first come to the mutation part to create a product. Here we have a class to create a product. Now we have to pass arguments like name, price. Now let me after executing. Yeah, the product is created now. Now move further to see the list of products. Here is the query to get all the products. Now here, after executing this, we can see our product is listed here. Now here I need to mention that these are the fields I want to get from the server. If I change any field, the response will be changed accordingly. Like if I remove the price, as you can see, price is removed from the response also. Now let's move to get the individual product details. ID 15. Now I am passing ID 15 here. Executing it, we are getting the details of ID 15 product, and I can change the arguments as per the need, and it will reflect as a response. After that, let's move to the mutation class to update a product. If I updating the data 15 ID product, we're executing it, I can see the 15 ID product is updated now. So there is one mutation class to delete this product. Now the product is deleted. You can see here. Now there is no product of ID 15. Right. Now back to the slides. These are some companies using GraphQL, like big companies like PayPal, Airbnb, Coursera, GitHub. These all are using GraphQL in their server side. Futures of GraphQL. As GraphQL developed by Facebook, its popularity increases by each passing day. The future of GraphQL looks bright with several exciting developments expected in coming years. GraphQL adoption has been steadily increasing over the years, and this trend is expected to continue in the future. We can expect better tooling and development environments for working with GraphQL. Although GraphQL was originally developed for using web application, it has potential to be used in other contexts as well, such as mobile and IoT. Moving to the conclusion part, GraphQL is a powerful query that offers many benefits for building APIs. It provides a more efficient and flexible way of fetching data from servers, enabling developers to easily customize data requests to fit their specific needs. With its increasing popularity and adoption, we can expect to see continued growth and development in the GraphQL ecosystem, including improved tooling, better performances, and expanded use cases beyond web application. Overall, GraphQL is a technology worth exploring for anyone looking to build high-quality APIs. So here are some resources we have gathered for learning purpose. You can use their documentation links to gather more information and deep dive into it. That's all from our side. If you have questions and doubts, you can drop it into our chat. Look.
Yeah, so someone has asked, like, is GraphQL library available in all programming language? Yes, it is available in almost, like, for almost all the programming language. But for every programming language, it will have different libraries for them. So you can use those libraries and you can use GraphQL along with that. I guess there are no questions coming. So yeah. So if after the session also, if you guys have any questions, so you can like reach out to us. We would love to answer them. And yeah, these are the email IDs where you can reach to us. Yeah, so I guess we can wrap up this session here.
Thanks, guys. Thank you for joining.
Thank you so much for
Thank you so
joining.
much for joining.
Yeah. Bye, everyone. Thanks a lot.